Here is January 2015, number 29. Solve the equation 4x squared minus 12x equals 7 algebraically for x. So we can't solve this until we set our equation equal to 0, and what we have to do is subtract 7 from both sides. So we have 4x squared minus 12x minus 7 equals 0. So there's a couple different ways to find x. We could factor, or we could use the quadratic formula, and I'm assuming that most of you are more comfortable with the quadratic formula right now, so let's do the quadratic formula. We have to find a, b, and c first. A must be 4, b is negative 12, c is negative 7. So using the quadratic formula, we'll have x equals negative b. Since our b is already negative, it's going to turn positive, so positive 12 plus or minus the square root of our b squared. Remember, you always want to put this term in parentheses so that when you square it using your calculator, it comes out as a positive number like it should, minus 4 times your a value, which in this case is 4, and times your c value of negative 7. All over 2 times your a value, which in this case is 4. So when you use the quadratic formula, you're always going to want to write this term out in front, plus or minus, write down the square root so you don't forget it, and then simplify your denominator. 2 times 4 is 8. In your calculator, what you're going to type in is this whole thing inside the radical, the negative 12 squared minus 4 times negative 7. And you type that in, and when you do, you'll end up with the number 256. And that goes inside the square root. So the square root of 256, it is a perfect square, so it turns out to a nice number. So this becomes 12 plus or minus 16 all over 8. So now we're going to have two answers. One will be the 12 plus 16 over 8, and our other answer will be 12 minus 16 over 8. So 12 plus 16 is 28, and 28 divided by 8 will give us a fraction. You can keep it as 7 over 2, or you can change it to a decimal, 3.5. So if you want, you could say x equals 3.5. And then your other root, the other x value, 12 minus 16 is a negative 4. Negative 4 divided by 8 is a negative 1/2. And if you wanted to write it as a decimal, this would be x equals negative 0.5, whichever you prefer, fractions or decimals. Number 30, graph the following function on the set of axes below. When you see this little bracket like such, you know you have a piecewise function. So there's really two different functions happening in one. And what you're going to do is you're going to make one big t-table, and this t-table will go from negative 3 all the way to 8. So, negative 3, negative 2, negative 1, 0. And because both of these have 1 in there, I'm going to actually use two different ones. 2, 3, 4, 5, 6, 7, and 8. Okay, there's my table. So, when my function is between negative 3 and 1 for x, I'm going to use the absolute value of x. And what that absolute value of x does is it takes any negative number and turns it positive, or if it was positive, it just stays positive. So the absolute value of negative 3 is just 3. The absolute value of negative 2 is 2. The absolute value of negative 1 is 1. The absolute value of 0 is 0. If you notice, negative 3 its negative 3 is less than or equal to. When you have a less than or equal to, or you have a greater than or equal to, you're going to have a solid dot when you graph the line. However, if you have a less than or if you have a greater than, there's no line underneath, it's not equal to, you need to have an open dot. So when we get to 1, if you look, this is less than, and it does not have an equal to sign on it. So when we get to 1 in this first function, it's going to be an open circle. And the absolute value of 1 is still just 1. Okay. Now, this all came from absolute value of x. But from 1 to 8, and notice they're both equal to, so they're both going to be solid dots. From 1 to 8, we are going to use the function that just says 4. So all that means is that we're going to have 4 as a y value, and that's going to occur in every x from 1 to 8. It won't go past 8, okay, but it's going to stop at 8. Alright, so now we can graph. So what we're going to do is start at -3 in the x, +3 in the y, and -2, +2, -1, +1, 0, 0, 1, 1, but remember this is open. So you're going to do, hopefully it's a lot neater than that, an open circle. Okay, now we're going to move on to our next function, and it's at 1, we're at 4 now. So 1, 2, 3, right here is 4, roughly. And then 2, 3, 4, 5, 6, 7, 8, these are all going to be at the same spot at 4. So 1, 2, 3, 4, 5, 6, 7, 8, right here. I'm just going to draw a straight line, and that's going to hit every spot. Okay. And the other one, I'm going to connect it like such. But notice that the two functions don't connect. They're separate. Okay? And that is it. That's all you had to do on how to graph this function. Number 31. A gardener is planting 2 types of trees. Type A is 3 feet tall and grows at a rate of 15 inches per year. Type B is 4 feet tall and grows at a rate of 10 inches per year. Algebraically determine exactly how many years it will take for these trees to be the same height. This is a little tricky because if you notice it says 3 feet, but then it says at a rate of 15 inches per year. We need to make sure that the units match up. So 3 feet is the same as 36 inches because there are 12 inches in 1 foot. So all I had to do was multiply 3 by 12 to get 36. In type B, that's 4 feet, and 4 feet, if we multiply 4 by 12, I'll end up with 48, and that's how many inches for type B. That's how tall the tree is for type B. So, I have 2 equations, and we'll say that type A, okay, we'll say is y equals, and I'm going to use 15, that's the rate, so it's like our slope, 15x plus, where we started, 36 inches. So that is our A. And type B will be y equals 10x, that is our slope, our rate of change, plus where we started, which is 48 inches. And that's going to be our B. And it says, how many years will it take for these trees to be the same height? Because it's asking for the same height, it's asking where are these 2 trees equal? So what I'm going to do is set these 2 equations equal to each other. So I'll have 15x plus 36 equals 10x plus 48. So let's move my x's to one side by subtracting 10x. I'll have 5x plus 36 equals 48. Now if I subtract 36 from both sides, I'll end up with 5x equals 12. And when I divide by 5, I end up with, let's just draw an arrow, x equals 2.4. And this is how many years? So we're talking about 2.4 years. Number 32, write an exponential equation for the graph shown below. Okay, so it's already telling us it's exponential. We can see that. It's clearly exponential growth, and the equation would always start with y equals, and if you remember, the formula is a times b raised to the power of x. A is your y-intercept. B is the growth value. It's what the function is being multiplied each time by. So, our y-intercept, and this is a little tricky. It looks like it might be 0.5, but really it's a quarter of the way up. So, it's really 1/4. Or if you wanted to write 0.25, that would be fine as well. And if I look here, at 1 I'm at about half, at 2 I'm at 1, at 3 I'm at 2, 4 I'm up to 4, 5 I'm up to 8. Okay, so I went, if this is my table, I have 0 is 1/4, 1 is 1/2, 2 is 1, 3 is 2, 4 is 4, and 5 is 8. What's happening between these y values is I'm multiplying each number by 2. So that is what my growth factor is. That is my b, 2. So this is my equation. Explain how you determined the equation. Well, what you would say here is that your y-intercept is equal to 1/4. Your growth factor is equal to 2. And that's where you can leave it as. Okay, that's how you know what the equation would be. And all this work above also explains how you determined the equation.